Hello everyone. So welcome to my new video after a long break. So yeah, as so okay, let's start. So I am starting a 30 days stop stammering, a challenge where I upload one or two videos of any of the topic and upload it in my channel, and I will try to not stammer and be stable. And yeah, so let's start. So today's our topic is Lagrange multipliers. Okay, so why I choose this topic? Because it is uh, optim it is constraint optimization algorithm. Means it is used, it is a um, um, way of solving a constraint optimization problem. So yeah, so let's start. Here we have given a function. So you know that whenever we have given any function and we want to find the maxima and minima of the function of one variable function, then you then we uh, find it by applying derivative and make it 0, so that, and we have the uh, boundary points. So if we have given any constraint, um, like uh, we have to um, go from minus 3 to 4, so we also have to take minus 3 and 4 in our solution. And in the uh, to to find the maxima and minima in case of um, two variable, we use Jacobian. Okay, and we use gradient descent to find the uh, maxima and the minima points. But the uh, problem is, if we have given a constraint that we have a uh, boundary, like here gx y equal to 0. So yeah, like gx y equal to 0. So here we have infinite points, so how we are able to check at the boundary um, of that given constraint. We can't do it, so that is the that is why of the Lagrange multiplier, means why we are using this. I think this is clear to you. So okay, so let's let's focus on how to solve the problem using Lagrange multipliers. Okay, so we have given an fxy, we have to either maximize it or minimize it, and we have given a constraint of gxy. So let me start from the basic. So you have to know first contour plots, and the second thing you know the gradient direction. Yes. Mm. And then you will able to understand. So if we have any of the function fx y is equal to x square plus y square, and uh, we want to draw the contour plots. It is a very good method to represent a 3D plot into a 2D plane. So fxy is equal to z. Okay, that is the value of the x square plus y square, and we make the plots like x square plus y square. So this is the, if this axis is y, it maybe z is equal to 2, z is equal to 5. Okay, so this is the contour plots where the value of z is equal at all the points of the plot. Okay, and yeah, what is the gradient direction? It is the steepest point of it is the it is it is the direction which which point to the steepest. Okay, so del f by del x and del f by del y, this is gradient. Okay, so if we have the curve, okay, so yeah, and we have, let me draw with the blue color. We have the curve, and we, when we take a z, small change in z, very very small, a change in the value of a z. So if we took very small, uh, it is like here it is blue, and here it is yellow. So it is like a straight line, okay, and if we steepest means where it changes its value fastest, okay. So if we go in any of the direction, okay, when we go in this direction, it has a component where the value do not change. So if we want to find the direction of the maximum change, we have to go perpendicular perpendicular in this direction, okay. So the direction of uh, gradient is always perpendicular to the contour plots, and the the beauty of this algorithm is we get a maxima and minima when we when the gradient of the fx y and gx y are pointing in the same direction. So that's the beauty of this algorithm. Why it it what is the intuition behind it? So let me explain it. So if we have an hyperbola xy is equal to, let me write, xy is equal to c. So it is like this we we want to find the uh, minimum. We want to find the minimum distance from origin to the hyperbola. So here if we have any of the point xy and we want to find the minimum distance, so we have to minimize this given it lie on, if we take xy is equal to 6, it lie here. So it is the gxy and it is fxy. Uh, First we have to minimize. So if you see both of them, okay, let me draw this and explain to you. I am drawing the contour of fxy, means x square plus y square. So okay, here it is like a circle. Assume uh, when we um, draw this, when we draw this larger circle, we have four inter intersection point, and when we draw this smaller circle, we have no intersection point. So when we go further, there is a uh, point where the tangent of gxy and fxy are parallel to each other, and the gradient of fxy is parallel to gradient of gxy. So we write gradient of fxy is equal to lambda gradient of gxy, and here we have one more constraint. Here we write, here this is our first equation. This is our second equation, and gxy is equal to c. This is our third equation. Three constraint, and we will able to solve for xy. And but many times it is not easy to solve these three equation equation. So we you 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 will study some of the matrix methods to solve this algebraic equations. And yeah, that's the video of Lagrange multiplier, and this is my first stop stammering a challenge, and I will upload the videos daily for around 30 days. Bye.